Okay, good evening everyone. Let's see if it works, and if it works then we can get going. So yeah, I'm basically waiting for a feedback on YouTube to see if we can hear ourselves, and if that's the case then we can start. So first, it is lagging, like there's like a 15-second delay today, but yeah, I can hear myself, so now I'm muted. Hello everyone, and good evening to my 40th English live stream. And this is Miki. I will allow Miki to introduce himself with a full nickname, name, as you know, I'm butchering the names always, so...
Hi everyone, and thanks Gimbal for having me. I've been into Bitcoin and cryptocurrencies for a long time. As someone would say before, it was cool. I would say 2010, 2011, and it's been a big passion of mine, and I'm really happy to be here to share some technical details and to talk about it and to answer your questions too.
Okay, perfect. So today's moderator is Krzaku. His nickname is somewhere here, as you can see. And if you have any questions, then just let him know. Be sure to use his nickname on either the YouTube chat or the IRC chat, and that way he can let us know that there is a question. And we're happy to actually take the questions. And by we, I do mean Miki, because I have no idea about this topic, so I'm quite curious about learning the stuff today. One more, or actually two more things before we get going. First off, there is no mission today. Sorry, there will be a mission next week. And second, if there will be any donations today, they will go to a charity of Miki's choice. So, but you know, perfect. So, okay, let's start. Okay, Miki. So, what's a Bitcoin?
Well, this is already a pretty good question, right? So, Bitcoin is a lot of things, right? You can see Bitcoin as a protocol, which is what probably most technical people would say, that Bitcoin is a protocol. Bitcoin is an implementation of a blockchain, and it's the first and the most important, I would say. Bitcoin can be a denomination of currency too. I mean, one Bitcoin means something. There will be a limited number of Bitcoins, so it makes sense to say what is one Bitcoin. But Bitcoin is divisible. Right now it's divisible up to 8 decimal places, right? So the smallest denomination is called Satoshi, in honor of his creator, who was under the pseudonym of Satoshi Nakamoto. And so Bitcoin is a lot of things, and it means a lot of different things for different people. So yeah, that's actually a pretty good question, and I don't think there's just one answer to that. Okay,
so let's start. You said that it's divisible, right?
Yeah.
Do they use floating points for it, or is it?
Well, if you're asking like how in the blockchain how it's stored, right? It's stored with right now it is stored in satoshis, right? And it is a var int, so it's an integer with like a special encoding to save space when possible. And basically, in the future, if there will be a need to split it by more than 8 decimal places, it is definitely possible to do it. It's surely possible to do up to 16, and with some modifications probably to 32, 64. So a lot of people, for example, say, right, well, I can't buy one Bitcoin, right? But one Bitcoin is really, really divisible, and you can buy a few Satoshis, you can buy half a Bitcoin, and well, the total number of Bitcoin that will be in circulation would be 21 million, and this is hard-coded in the protocol and would require a hard fork to change that. So basically they will, well, we can talk about consensus and forks later, maybe. This would be pretty steep start.
Okay, so you said mine. What does it mean in terms of Bitcoin? How do you mine a Bitcoin? So I guess you buy a pickaxe and you go to in the mountains to a cave, and I've done it in Ultima Online. Is that the case, or how do you do it?
Or in Minecraft, right?
Or in Minecraft, sure.
Yeah, so mining a Bitcoin, right? So basically this whole thing, right, that, the network validates transactions, right? And there is what is that secures Bitcoin, right? So we can talk a little bit how it works, what is a block, what is a transaction, and so on. But the important thing is that there is a hard problem, which is more similar with the proof of work that is into Bitcoin. It's more similar to a lottery, actually. There is a hard problem that a lot of actors are trying to solve, and they compete and they race to solve this problem. So basically what the Bitcoin network aims to do is to keep the rate in which blocks are generated statistically fixed. So they have basically depends on how much computing power you throw in the network. There is a parameter, it's called difficulty, that gets adjusted, and this makes so that blocks are valid blocks are generated every 10 minutes on average. And this guarantees stability and makes the network go on in a secure way. And the fact that not just everyone can generate block, but you need to put serious processing power makes the blockchain secure in a way. So one of the properties of blockchain is that they are immutable. So basically it becomes exponentially more and more hard to counterfeit a block, because when new blocks are added, you would need, because of some properties that are like basically the same properties of Merkle trees. So basically there are, every block has the hash of the parent, so you would need to undo all the history back to the block you are modifying, and it becomes really expensive. You would race against honest miners, and even if half of the network becomes rogue, they would still be pretty hard. Like right now, the processing power put into Bitcoin is I believe around I think it's more than 80,000 times the top 500 supercomputers together. So it's in terms of flops. I mean, this is hard to quantify, but I read something about that. Yes, it's pretty interesting. There are other ways that are not based on proof of work to secure the network. For example, it's proof of stake, like Ethereum. There are some papers that are suggesting that some kind of proof of stake are as secure as proof of work, but there's also some controversy about that. We know that proof of work is secure. We don't know if proof of stake is as secure.
So, okay, so technically about the Bitcoin, right? To mine it, you have to brute force a hash, right? So what kind of hash is it? You said that there's a difficulty, and also what actually are you hashing?
Yeah, so maybe I can show something like what is a block, what is a transaction right before. So
let's
awesome. Great. So here I am on.
Oh, sorry.
Okay, where am I? Okay.
Sorry, for LCDs, awesome. So it's hard to spot the mouse. Okay.
Okay. Yes, I see it now. Thank you very much. So basically, this is a blockchain demo. It's let's say a toy example of how blockchain works. And so for example, this is a block, right? So you have transactions and you have blocks. So basically blocks embed several transactions. So when you issue a transaction, so a payment, there is a network, is a peer-to-peer distributed network. And every node gets like the transactions that are put in a pool, and it's called memory pool. And the miners can choose some of the transactions to embed them in blocks. And basically they choose them usually on a fee-first basis. So basically they embed first the ones that have the higher fees, or more specifically the ratio fee over size, because of course there is a limited size to a block, which used to be 1 megabyte. Now with segregated witness, it's variable, and it has an upper limit of 4, but like more realistically now we are between 1 and 2. On average. So basically this is a block, right? So what do you have? This is a simplification of a block. You have a lot of more things, and we can also delve more into detail. But let's say that you have some data, right? And the data are, you can think that all the transactions are here, right? So for example, I just put something here. You see that when I type, the hash of the block changes, right? So there is this thing which is a number, and it's a random number. And so here you can think that all the transactions are here. And here is something that the miner can change. So if you see the hash now, it starts with 8 in a hex form. So the Bitcoin network says that a valid block has to have a number of leading zeros in the hash. And the number of leading zeros, or well, the logarithm of it, is called difficulty. So the more hashing power is put into Bitcoin, the more leading zeros you need. So for example, this is not a valid hash because it doesn't start with 0. But if you mine, what you're doing, you're just trying to find a number. In this case, the difficulty is 4. So it is a toy example, so that it works on JavaScript in this browser. And you see this is a nonce, right? So maybe there would be another nonce, but this is a valid block, right? So a blockchain is actually like a chain of blocks, right? So you have several blocks, and you don't just have a hash, but you also have the hash of the previous. So for the first block, the hash of the previous is 0 because it's what the first block is called Genesis block. So it's the first one. So for the second one, you have to mine this one. And see, you have found the right nonce. So this is propagated to the network and everything is fine. Here you have another block, hi there 2, with some other transactions. You see it embeds the previous transaction hash, which is the hash of the previous one. And if you know about Merkle trees, this is very similar to Merkle tree, but it is, well, not really a tree, it's just a chain. So it doesn't have, you know, bifurcations. Well, it does have bifurcation, but they are not what makes them work. So here you see we found a nonce that also including the previous block, right, makes the block valid. So we mine a third block, and see, this time it's taking a little bit longer because the nonce had to be higher. So if anyone wanted to modify this block, you see that immediately all these blocks, the second and the third block, became invalid. So what you'd have to do is to mine back the second one and the third one, but in the meantime, another peer would have probably mined a valid fourth one on top of the valid previous third one. So you would really need to have a lot of hashing power to be able to overwrite history. So this is how proof of work secures a blockchain. Okay,
so what's the current difficulty in the Bitcoin?
We can definitely see that. So there is my favorite site for stats about Bitcoin is satoshi.info. You have a lot of well, when it works, you have a lot of stats about Bitcoin and graphs.
Okay, so I load.
Yeah, but
I see there are, sorry, a lot of questions already. We'll get to answering them while we actually, after we're done with the basics. So in 15 minutes probably.
Very looking forward to the questions, by the way. Yes, because there's a lot to talk about, right? I mean, Bitcoin is well beyond, right, the technical details, but I like to talk about the technical details. And oh wow, awesome. Okay, so I guess when Bitcoin broke the 10K, a lot of people are getting into Bitcoin, and they are probably DDoSing most of the sites. But anyway, this is the difficulty, the hash rate. So there are so how good are you with prefixes? So this is peta, exa. So it's probably 8,000 exa probably. Yeah. So yeah, you can also do that in flops, and it goes up. So when you see these dips, so these are estimates, right? So this dip was due to fork in Bitcoin when Bitcoin Cash was. So some miners moved to Bitcoin Cash, and then they, of course, after manipulating the price a little bit, they went back to the main chain because that's what they were losing money actually by staying on the wrong chain. And difficulty is this red line. You can see that it adjusts, right? So when hashing power goes up, it goes up, and vice versa, right? So it aims to keep the average block time fixed to 10 minutes. So this is, you can also go to blockchain.info. It has some interesting stats, and yeah, this is a terahash. It's a pretty large number for terahashes. It's 10 million, right?
So is it per second? Per second? Okay.
Yes, it's terahash per second. So yeah, so hashes are SHA-256 hashes, right? Because the proof of work is double SHA-256 for Bitcoin, and so on. Yes. So yeah, this is the right. So if you want to see what's going on right now, this is live view of the recent blocks, and transactions that you see on the lower right are happening live. Yeah, you see, for example, the time since the last block is a little more than 1 minute right now. We have around 4 transactions per second, which might not seem much, We can also talk about scalability, SegWit, if you guys are interested. And these are the fees, and these are the blocks. So, yeah.
Okay, perfect. So let's skim through the questions and let's see if there's something which we can already answer. There's one question. The first question is about cryptocurrency vulnerabilities. We will get to that, so let's not answer it yet. Oh, that's a just question for today. Is like, how in depth is this gonna get today? I guess the answer is here, we'll see, because we might get really in depth in some topics, and then we might actually like just mention other topics. So we'll see. We do have limited time, so we'll see. Okay, so here's a just question from Derba Supervisor. What is the difference between Ethereum and Bitcoin from a technical side?
Sure, well, yes. So these are two very different blockchains, and they come with different objectives. And also from a technological point of view, they're very different, right? So first of all, after the recent hard fork, Ethereum is no longer a proof of work blockchain. So there is no, I mean, there is still mining, but it's not by doing complex calculations. It is by proof of stake. So it's basically old coins generate new coins, right? With a particular formula and some adjustments. But mostly the main characteristic of Ethereum is that it allows the creation of smart contracts that are very powerful. So you might have heard of Turing completeness in a completely decentralized way, right, and trustless way. So the idea is to have this universal computer that shares a global state, and block by block, so it's actually not really Turing complete, right? It's what is called rich statefulness. Basically, it's sharing a rich state across nodes. So basically what you can do things such as with an oracle, you can do smart insurances, like you can, I don't know, you can allow other people to contribute to your micro insurance for your flight tomorrow, right? You can say, let's just go to via an oracle, but you can do things like let's query 3 APIs. If my flight was late more than 1 hour, then you get all the funds that people put it. Otherwise, they go back to the people that put the money there. So for example, this can be done in a completely decentralized way, and code is law, right? This is the idea of smart contracts. So the code becomes law, which is also a very interesting concept, because this is not how contract law works in the real world, right? So the spirit of the law is what counts in a court of law. It's not the letter. And the code has bugs, right? So we've seen a lot of smart contracts failing clamorously, like for example, the DAO, the DAO failure is a chief example of this. And
so can you give some details on that example, like what happened there?
Yeah, so basically the programming language that is used, there are a few programming languages over the Ethereum virtual machine, right? So the most used one is called Solidity. And it is, I would say, my personal opinion is that it's not a particularly well-designed language, because it has some defaults that are very dangerous, right? So for example, the visibility defaults are problematic, and there are other technical issues. So for example, reentrancy is an issue, and you have to take care of the reentrancy problem explicitly, and this is very error prone, and you shift a lot of checks that probably should have been done automatically by the framework, at least, or the compiler, to the programmer. So for example, the DAO, in the DAO, so the DAO was this idea of having a decentralized autonomous organization. So this idea of basically creating like something that would run by itself by collective voting, so everyone could vote with their tokens, and could, for example, decide what would become law, and so on. So this idea of a new generation company where everything is decentralized, everything is truly democratic, right? And this was even combined with some pretty ambitious political ideas that would if you Google, for example, for future key, you would read a lot about that. It's pretty interesting. So, for example, betting on outcome, agreeing on metrics to define an outcome in a political setting, and then betting on ways to get to that outcome is apparently more effective than just electing representatives and then trusting them to do the right thing. And there are actually some scientific foundation to that. But anyway, it was a very ambitious project. And what happened is that there was a hack due to a reentrancy problem. There were actually a few vulnerabilities. So one was a reentrancy problem. And what was possible to do is was basically possible to make like the contracts call themselves, and it was possible to exfiltrate funds. So what happened is that an attacker was draining the DAO with like these tokens and these funds that the people put in, and Ethereum had to hard fork to basically ban the addresses where these funds were stolen. And this set a kind of dangerous precedent, because it basically showed that Ethereum in its infancy is kind of a centralized cryptocurrency. It's not like Bitcoin. It's it has a foundation that actually cares about these kind of high-profile thefts, and is willing to take action to revert problematic fraudulent transactions, which is not, for example, this will never happen in Bitcoin. So also from a legal point of view, that's pretty interesting, because code was not law in that case. So the hacker played by the rules, right? There was a vulnerability there. So it's pretty interesting. So the spirit still won, and the letter, or in this case, the code, didn't. So maybe one can ask himself, right? Is it what we want for the future, like contracts that are self-executing, or we still need someone to decide the spirit of the law, which is very interesting.
Okay, cool. So let's move on through the list of the questions. Okay, current hash rate is, I cannot even read this number, but it's pretty...
Yep, that's a lot of...
what is this? Is it like 10...
It's following the XR, right?
10 million terahashes.
Yes,
Sorry for saying million tera. I know that sounds stupid, but I don't know what's...
Sorry.
I don't know even how to say it. Okay, so, okay, what are the fees? In a Bitcoin transaction, what's a fee?
Yes. So let's. Oops, sorry.
Excuse me.
Sorry, that was your person, I guess.
Sorry. Yeah, no.
Okay. Yes. So let's see what are Bitcoin fees. So basically, originally, so a transaction has inputs and outputs, and we can go as deep as we want into that. We can maybe see what is the scripting language, what is a transaction, like basically byte by byte, which will be also very interesting. But the important thing is that you can put a voluntary fee in a transaction, and this fee makes your transaction more likely to be embedded in a block by a miner. So as I said, when you broadcast a valid transaction, the transaction gets validated, and if valid, gets put in a pool, which is called memory pool. So the memory pool is what you see here, for example. This is the memory pool. This is a transaction per second. Actually, we can do size. Okay, so the memory pool is around 35 megabytes, and it is 35 megabytes of transactions, right? So it is 61.9K transactions that are in a limbo, let's say, right? They are waiting to be embedded into blocks. So what you can do to make it actually happen, so it's to provide an incentive. Since the block size is limited, you have to spend a little less than your inputs for your outputs. So basically, your inputs have to be a little bit more money than your outputs. And the difference goes to the miners, and it's called transaction fee. It is completely voluntary. It's usually measured in Satoshis, which are the 10 to the minus 8th Bitcoin. Usually the measure is Satoshi per byte, right? Because the transaction can have different size. And of course, the larger the transaction, the more fees you should put, because it takes more space in the block. So right now, the cheapest transaction fee for an immediate confirmation is 190 Satoshi per byte. So very likely you can estimate a delay, right? For example, if you put just 100, you'll probably have to wait from 30 to 900 minutes. So I found that this estimator is pretty good. but sometimes it's a little bit on the conservative side. So if you're looking to, so wallets usually do fee estimations automatically, but most of the times they're very, very, very conservative. So most of the times you can put half or even less than half of the fees they suggest. And basically, the more fee per size you put, the faster it gets, right? We can also talk about how safe it is to accept 0 confirmation transactions or 1 confirmation transactions. Do you need to wait for 6 confirmations, how it used to be in the past, or not? And yeah, the answer is not, but...
yeah, let's talk about it. So you just said that you have to wait, that if you pay like 100 satoshis per byte, then it's, or like, when it's immediate, right? By
Yep,
immediate, we mean 10 minutes.
On average. So it
On
depends when the next block is mined, right? So for example, if you go here, you see last block was mined 11 minutes ago. So this is already over median, right? You can expect a block to be mined anytime soon, but the variance is your enemy or your friend, so it can take 30 minutes, right? It is pretty rare that it takes more than 30 minutes, but it's definitely doable. So for example, like these ones had to wait, you know, these last two were 5 minutes apart. So this was less than ever. So maybe now it will be 15 minutes, right? On average, it will be 10 minutes. And the average block rate is 10 minutes on Bitcoin.
So question, here we have latest transactions and they're like updating all the time. Is this what goes to the mempool?
Correct, this is the transactions that are appearing in the mempool, yeah.
So, okay, so a transaction arrives at the mempool, right? And I guess the miners get notified that there's a new transaction, and they include it, and they have to basically rehash everything and calculate the hash again from the all the mempool.
So basically, since it is memoryless, right, just changing the nonce or scrambling the transactions is just a matter of their internal optimization algorithm. So basically, you can see it like from a theoretical point of view, it is a kind of a discrete knapsack problem, right? So you have to optimize a resource, which is fees, right, in a limited space. And you can do it with either modifying a nonce or adding better transactions, or both of that. So usually it is a little bit more expensive to you know, you have to put other transactions, removing transactions, adding new transaction, but this is done all the time, right, to maximize the fees, because well, we can talk about it, but the reward gets halved every few blocks.
Reward for mining.
Yeah, so basically there is a Coinbase reward, which is like how new Bitcoins are generated. Right now it's 12.5 Bitcoin, it's already halved twice. Started with 50, then sorry, 3 times. It started with 50, then 25, and then 12.5, and then there are fees, right? So for example, if you look at the last block, right, the last block had an average fee size of 167, so it's very likely that if you paid more than that, you would get in immediately.
So that's satoshis.
Satoshi per byte, yes. What I wanted to show is, yes, so this block has 1.64 Bitcoin in mining fees, right? And 12.5 in block reward. So the Coinbase, the so-called Coinbase, is how new currency gets generated, right? And this goes down, it follows a geometric progression. And as you can see, it's already more than 10%, right? What the mining fees are. And in the future, when there will be 0 block reward or very low block reward, the fees will be more than the block reward. So in the future, it will be more important to actually keep updating the transactions to push out the cheapskates and get in the ones with highest fees.
Okay, so even if the block reward gets to like 0, I guess, at some point, or close to 0 at some point, then people mining will still get the reward as in the fees.
Yes.
Okay, perfect. Cool. So let's, I guess that answers the question, what are the fees? And let's look. Okay, so did we touch already on the transaction size versus the Bitcoin sent? Do you want to talk more about it?
Sure. Most about what influences transaction size, if you understand the question correctly, right? So the transaction size is directly proportional right now. To the number of inputs mostly, and in a minor way also to the number of outputs. So I say that it is more dependent on the number of inputs for a simple reason. and we can go in detail how a transaction is from on the inside, right? So yes, let's do this, because this is a pretty simple. So there are different transaction types, right? So this is the simple original, like Satoshi style transaction. So this is what it's called pay to public key hash, and we see what it means. It's a P2 PKH if you look into Bitcoin documentation. So what is it inside this? So let's get the transaction ID, and let's try to get exactly what byte by byte what is inside this, and this will also answer the question what is that influences the block size, because you see exactly what's inside that. So I use this API, but you can also use your Bitcoin client. This is chainquery.com. If you execute the command, you see, so basically there is one input, right, which is this one.
Let's make a total.
Oh, yes.
So this was this one, right?
Yes.
Okay.
Awesome. Yes. Thank you very much. Okay, so there is one input, right? And the input is this one, right? The one AZ. And there are two outputs, right? This is typical, right? To having two outputs. And I'll see later maybe why it's typical to have two outputs.
So that one A something is the public key, right?
So
sorry.
This is an address. So address is a hash of a public key encoded in a format that is called base58 check. So it's a base58 with checksum. Its regular addresses start with 1 always. Pay to script hash addresses start with 3, and yes, let's say like that for now, because I mean SegWit also introduced a new way of writing addresses, which is another encoding, but this is a kind of advanced. So as I said, there is this thing which is historically called script sig. So I don't like to call it script sig, because I mean, from a normal transaction, it is a script sig, it's a signature of a script. But more in general, it's an unlocking script, and we'll see what it means in a while. So the important thing is that you have a signature per input. And what this input does, what this signature does is proving that you own the private key of that address. So you are authorized to spend it. It does not just assure that, it also assures non-deniability, non-repudiability, and a few other things. Outputs basically just have the public key of the recipient address and not more. So we'll see what this means in detail, like a dupe, hash160, and these things. What do they mean? Okay, so what we're doing now is getting the hex of the input, and yes, so this is the script seg. Awesome. So let's just do this. Okay. Yes. And here the pub key, we get the script pub key. So input before and then output. So yeah. Okay. So Bitcoin has state machine. Well, it has a language which is called script that is stack based. It is intentionally non-Turing complete, and this is because verification happens on every node, and you don't want complexity to explode, right? It would make verification a vulnerability by itself if it was Turing complete. So this is also a point of disagreement with Ethereum. Like Ethereum wanted to be very powerful, so they had to introduce this concept of gas that basically throttled computation. Anyway, so what happens is this. So to spend, like you have a puzzle, which is this, this pub key. So pub key is this. This is the puzzle. So basically outputs say what has to be done to spend this output. And it is like duplicate, hash, public key, equal verify, check signature. And a spender would just need to push on the stack two things. The digital signature proving that the person owns that public key, so that address, and the public key itself. So
it was the signature. How is it calculated?
So this is actually pretty complex. So the signature is signature with ECDSA over the whole transaction.
Okay.
And it's, as it said here, the entire transaction's outputs, inputs, and scripts are hashed, and then they're signed. So let's see if this transaction is valid. So I copied.
Did you copy the public key correctly?
Yeah, I think
Could
so.
you double check?
Yeah,
Okay,
you see,
so-
right? Worst case, it will fail. So, okay, so it pushes these 71 bytes, which are here. You can see it's a 030, I guess. Let me check.
So could you
Yes.
scroll a little down? Our camera, I think, is blocking
Ooh.
that part.
Yes, I will. Okay, sorry. So this is the digital signature of the spender unlocking the script. So this is the unlock script first. It pushes the public key, saying basically, I am this address and I own it. Okay, so I own it, and this is my address. So the address is a hash of a public key. Okay, so you can think it's a public key basically. It's ripe MD hash of SHA-256 hash of the public key. And there's a reason for that, but it's a little complex. So you duplicate, then you do that. You do ripe MD of SHA-256, which is this hash 160. You get 68. Then you push. Okay, this is not gonna be valid, and let's find out why. So I probably didn't push the thing correctly. So this is the pub key, right? So, so the pub key was right. Sorry, let me check, because sometimes I maybe put the wrong way. No. Okay, so let's try to do that again. Okay, so let's take another transaction. Okay, so I probably mistyped something. Okay, so let's get this other transaction, which is similar. It's just 1 and 1. Okay, so what we have here is, okay, so here's the script signatures of the input. So this is the one with the digital signatures and the public key, and it is here in the script signature 4830, as you can see, as this one. And this is the pub key 76A, right? So you push the digital signature, you push the public key, you duplicate, you hash the top item twice, you push the 5E, which is let's get this. Where is the 5E? You verify, yes, you verify that they match, and then you check the signature. So this check signatures is mocked to turn true because it doesn't have the whole transaction. So this is just a toy. But the important thing is you have, so in every input you have a large signature, which is ECDSA signature. Then you have a public key, and then you have a puzzle for each output that says you have to own this public key, so the private key to this public key. So in the curve that is being used here, which is the NIST SEC256PK, the private key generates the public key. So just having the private key is enough. You just multiply it by G, the generator of the curve, right? As most elliptic curves. So the important thing is the size of the transaction is mostly given by the number of inputs, because this, as you can see, the signatures dominate in space. Okay, so this is fixed size, right? But it is smaller, right? The outputs. So the more inputs you have, the larger is the transaction. So for example, let's get I don't know. Oh, these are all one input. But anyway, this is 3 inputs, right? So this is 3 inputs, and it is 486 byte. See, it's 486 byte. If you get one with, let's try to get one with more. It is S5. It is 975. See how it goes up? Because all the input scripts, see, this is digital signature, sorry, digital signature key, digital signature key. So this will change. Actually, this already changed with segregated witness. So basically, this part is no longer part of the transaction. It's part of a separate data structure. It's called witness. Witness is a term that comes from cryptography and cryptographic witness. And basically, what it aims to do is a few things. It's to solve scalability problems or to help solving scalability problems in Bitcoin. The major thing is that it makes transactions smaller, so you can have lower fees. And also a few other things. It solves transaction malleability and at least third-party transaction malleability and a few other things. So yes, I hope this was enough to answer the question, but feel free to ask more.
So I guess the question is also in this case about scalability. So what's the problem with why is there a scalability issue in the Bitcoin at all?
Yeah, so yeah, this is like a huge debate. So okay, so okay, let's see live what's happening right now on the Bitcoin network. So
27 minutes to no Bitcoin.
27 what? Yes, see, we are unlucky right now. By the way, the price is severely dropping, and this is, well, not particularly interesting. I don't think price is the most important thing in Bitcoin, but there is some volatility around 10K because, you know, psychological markets, a lot of zeros, and it's really going down. Anyway, what I wanted to show is that, see this size. So blocks are, and then here I put some huge quotation marks. They are full, right? We are around 1 megabyte, which used to be the legacy limit of a Bitcoin block. And the transaction per second is right now between 3 and 4 transactions per second, which is definitely very far away from what Visa, MasterCard, or a payment or a truly global payment system would have, right? Which would be probably around 100 or so. Okay, so what is Bitcoin, right? So is Bitcoin a payment system? Is Bitcoin a currency? Is Bitcoin a store of value? Bitcoin is a little bit all of them, right? And Bitcoin is being used right now mostly as a store of value, and there is proof of that. I mean, 2/3 of the Bitcoins are basically being hoarded, willingly or not. Sometimes you lose the private key, so you are forced holding. But it's basically provably deflationary currency because it's deflationary because coins get lost and they get destroyed. So the supply is, you don't have inflation, you have actually effective real world deflation. So if you buy a deflationary asset, you can expect, if demand keeps up, that the price goes up, right? So it is definitely a store of value, and in a way it is much more liquid and fungible than gold, right? So a lot of people use it as a store of value. But some people say, well, it also has to be a fast and a cheap global means of, for example, I don't know, doing remittance payments, right? The remittance market is a very interesting market, right? So Bitcoin is truly distributed, it's global, it doesn't have borders, right? So this looks like an ideal, use case. So the problem is, once we approach the limits of the block size, fees have to necessarily go up, right? And fees have gone up historically. I would show you the great Satoshi.info graph, but unfortunately, the site is down now. It's very, very nice. It's from 2009. You can see really how fees went up. So there are a few ways of dealing with these scalability issues. The first one, and the simplest one, right? So the simplest solution in engineering, I would say, is not always the right one, right? So if you have a lot of traffic, what can you do? You can build larger roads, right? This is the simple solution. You just build 1 lane more, 2 lanes more. So this is what some people want to do. So they just increase the block size to 2 megabytes to 8 megabytes. And that's enough. But so for now, it's enough. They just basically delay the problem of maybe a couple years or maybe even less. the downside to this solution is that by having a larger block size, you make the currency less decentralized because you need more bandwidth, you need more computing power. The whole blockchain is pretty large already. It's already around, I think, around 400 gigabytes in compressed form, and having 8 megabytes would easily make it a few terabytes. So you will need probably specialized hardware, and you can't run it on a Raspberry Pi as you can now. Now you can run it on a Raspberry Pi B. So another way, and this is called on-chain scaling. So just keep all the transaction on-chain, so on the blockchain, but basically make the blocks bigger. The alternative approach is to change how transaction works and move some of the transactions off-chain, out of the chain, to free up space. You can do that with what is called layer 2 solutions. So they are not on the blockchain, but they are linked cryptographically to the blockchain. So they give the same security guarantees of the blockchain, but they are, for example, based on payment channels. And here, the most important implementation of L2 payments is the Lightning Network that required segregated witness to work. Actually, it didn't require it, but it would make their life much more simple. So, and change how transaction works. So for example, separating the witness freed a lot of space also. And the segregated witness, which is this change that happened, also made the block size variable, but not as big as the big blockers would have wanted. Okay, so basically so Bitcoin Core, so the traditional Bitcoin, opted for an off-chain solution. So they implemented, the network implemented, there's no one controlling Bitcoin Core. It's a lot of actors. It's the miners, it's the exchanges, it's the users, it's what is called the economic majority, right? And they opted for an off-chain solution. And this is what we will be seeing. So we will use probably the blockchain as a settlement layer only, and it will not be a digital cash. But some people say that this is betraying the original vision of Satoshi Nakamoto, which put in the title of the white paper that Bitcoin is a peer-to-peer digital cash system. So, for example, they created a fork of Bitcoin called Bitcoin Cash that just rejected, outright rejected SegWit, and just increase the block size to 8 megabytes, right? And then we have other things that are, so let's say, of historical value. Some happened, some didn't happen. Some were like trying to find a compromise. So, for example, as part of the New York Agreement between miners and exchanges and so on, there was this idea of having both SegWit and a twofold increase in the base block size. It was called SegWit 2x. It didn't see the light. It was scheduled to happen a few weeks ago, but it didn't happen, and so on. Yeah.
Okay, so the scalability problem is related to the size is 1 megabyte now, and
so the size now is variable, right? So with SegWit you have a variable size that can be up to 4 megabytes, if I remember correctly, but more realistically right now it's between 1 and 2 megabytes.
Okay.
SegWit adoption is still struggling a little bit, and it's probably also because some of the wallet creators are a little bit dragging their feet because they were not really happy about SegWit. So let's say miners, for example, have an incentive to have everything on chain because they get fees out of that, right? While, for example, if you want to sell solutions for off-chain payments, you want the other way thing, right? So usually there is this clash of interests, like, for example, Blockstream, which is awesome and company employing very, very competent engineers on the blockchain field. Is sometimes accused of wanting to, move away from Bitcoin and selling solutions for payment channels and so on, while miners are accused of wanting everything on chain and just getting all the fees for them.
Okay.
And being short-sighted in a way, right?
So. Okay, let's go for the next question then, which would be, let's go from web now. Or before we get to that, can you tell me what's a Bitcoin wallet?
Yes, so a Bitcoin wallet in the simplest form is software that has a collection of your public key. Sorry, basically it has all your private keys, right? Or it has a way to derive your private keys. So usually how Bitcoin wallets are working right now, they are deterministic, hierarchical deterministic wallets. So they have a seed, and which is usually represented in a mnemonic way, which is usually 12 words, of which one is a checksum. And from those words, there is a key-based password-based key derivation function that creates a 512 bits, I think, key, and then by adding a number, an increasing number to the path, you can generate all the addresses you want, and just having the seed, you have the private keys of all those. So it's important to keep separate addresses for privacy reasons, because otherwise you can be tracked, right? Bitcoin is not anonymous, it's pseudonymous, and we can also talk about that if you guys are interested. But for privacy reasons, it's important to keep separate addresses for separate transactions, and not to reuse them if possible, right? Yes, so basically a wallet, also the wallet creates a concept of balance, which we are used to. For example, if we have a bank app, or you go log into home banking, and you see you have $1,000, right? So the concept of balance is not really that easy for Bitcoin, because your balance is all the unspent transaction outputs that are in the unspent transaction output set, of which you can spend, of which you have the private key. Okay, so basically it's a kind of a complex operations. You have to go through that and see which ones you can spend, and then sum the values. So it does that. It also provides sometimes integration with exchanges, sometimes, and it allows, for example, to scan a QR code. You scan a QR code, you put the amount, you send, and so on. So wallets can be full nodes, so they can be fully validating. They could be light wallets, so SPV. They just have the headers, and they use a server that has to be trusted to validate correctly, and they use usually a Blum filter to see to basically get the balance and so on, and do this kind of operations. Running a Bitcoin full node right now requires mostly kind of a lot of disk space, right? It's around 400 gigs if I remember correctly. And so it's not for everyone, right? You probably can't have a full node on your phone. I mean, you can. There is for Android, there is a full node. This is Bitcoin Core basically, but that's a little bit hardcore. Also because you have to sync the blockchain. You have to have the blockchain synced all the time, while you don't have for Light Wallet, right? And yeah, and for most applications, Light Wallets are secure enough. What are not great are wallets that let's say banks, right? They're not wallets. You don't own the private keys there. So for example, they are multi-sig, and you have just one key, but you also need their key to spend them. And some wallets have so-called wallets. I don't call them wallets, but unfortunately they are advertised wallets. I have like that. So if you're looking for a wallet, you need to make sure that you own the private key. So one important thing in Bitcoin land is you don't own a Bitcoin if you don't own the private key of the address that has the funds.
Okay, so okay, speaking of wallet, what have you brought to us today?
Yes.
For us today. Yes.
So I brought a few things, and
it's a show and tell day after all.
Yes, they're okay. So first of all, I wanted to recommend a book by Andreas Antonopoulos. It's Mastering Bitcoin by Aurelie. So this book is open source. If you search for Mastering Bitcoin 2nd edition, you'll find a GitHub, and the LaTeX sources of it with all the errata are there, and you can just download and compile it. There is a makefile, and if you want, you can buy a paper copy, but you don't need to. So I feel very comfortable in recommending it because it's very nice. It goes pretty deep into technical aspects, and it's still very comprehensible even if you don't have a technical background. I guess most of you have a very nice technical background, so you will definitely appreciate. It teaches you basically how to implement, how to do a transaction from scratch with Python and basically see all the problems that Bitcoin has to go through and how they solved them and so on. It's something, it's really, really nice. And secondly, well, I have some cards here, and these are like, oh, I don't know if you can see them, but they are like aluminum.
Move it closer.
Yes. Okay. Okay. They are aluminum cards, and here, whoops, there are like QR codes of your addresses, and some of them, these are very nice, and they have like public key and encrypted private key, so you can try to brute force them if you want, but they are encrypted with script with outrageous number of iterations, so good luck with that though.
So where did you get them?
I don't remember. I think I got them like in 2011 or so, but they are a really nice way to like make other people scan for your address even if you don't have a wallet right now.
Like a business card. Instead of a business card, just show them like this. Okay, that's awesome.
And then I have a hardware wallet. This is a Trezor. So this is a hardware wallet that does all the signing of transactions, broadcasting for you, and it assumes that your host computer is compromised. So basically you have a seed, which is also password protected, and you have a pin, which is on screen, so it is scrambled. Basically all this in their threat model, they put everything is compromised. So if you lose your seed, it's still, and someone gets the seed, it's still not enough to get your Bitcoin, okay? Because you need the passphrase. If you get the passphrase alone, same. If they steal this, you need the passphrase and the pin, more than this, right? So you basically need a lot of things, and also it's possible to have plausible deniability so that you can have a fallback passphrase that shows another wallet, and which, well, shouldn't be empty if you want to be believable, but this provides plausible deniability. It is very nice. It is open hardware. Trezor is open hardware. There is another one which is maybe it's more known. It's the Ledger Nano S. I'm not sure if the Ledger is open hardware. I don't think so, to be honest. But yeah, it's also a very good one. It's also a little bit more user friendly. But if you're a technical person, the Trezor is very, very nice. And lastly, I have a collectible which I wanted to show. This is like from 2011. I don't know if you guys can see it. It's used to be 25 Bitcoin, and it was from guy called Casasius. He used to mint them. And here there was a tamper-evident private key behind a hologram. And this is just a very nice collectible, and now they're also worth quite a little bit. And it's basically owning a little bit of the history of Bitcoin, and wanted to show you guys.
It's pretty awesome. It's like, it's not pure gold, but it's still shiny.
It's definitely not. It's definitely plated, but it still have collectible values. Right?
Perfect. Okay, let's go through the questions. So, by the way, that Bitcoin block is still being mined, unless the...
This is very exceptional, right? More than 30 minutes is definitely exceptional. So either this is like the Explorer is not working, or it's it happens, right? There are sometimes even 1 hour, but this is like, it happens less than once every few weeks, right? But it's definitely doable, unless there is an attack on the network, like miners leaving the chain, which is probably not what's happening.
Okay, we'll see in a second. So, what about cryptocurrency vulnerabilities? That's a question. Can you give some examples, or maybe tell some scary stories about it?
Right. So the potential for vulnerabilities in implementations of cryptocurrency, I think it mostly is in. It lies mostly in, well, it can be in the protocol itself, especially for cryptocurrencies that are not that well tested. So I'm not talking about Bitcoin here. I'm talking about altcoins, right? So currencies that are derived from usually an old version of Bitcoin, and they haven't patched. They tried to, they have a small development team, and they are, they're doing things maybe they don't even understand very well, and so there might be some protocol mistakes. Even if the development team is very good, such as the one in Monero. Monero is a privacy-focused cryptocurrency, and the protocol is called CryptoNote. It uses ring signature to basically provide unlinkability. So it makes it's impossible to, or very, very hard to link the inputs to the output. So who paid whom? And CryptoNote had a pretty interesting vulnerability in the protocol itself, and that allowed, if I remember correctly, even to generate currency, which is very bad. This would probably not be possible in Bitcoin, right? So even if SHA-256 would be broken, or the curve, the P256 would be broken alone, that would not make it would not be a big deal for Bitcoin. Both of them might allow some easier rewriting, but for example, new currency would not be generated. There are some more cutting-edge cryptocurrencies such as Zcash, which is based on very complex cryptographic scheme, which are called ZK snarks. They are zero-knowledge proofs and commitment schemes, and they are like kind of magic, right? They allow to, for example, verify properties of without being able to decrypt them. So it's in that particular aspect, they are similar to homomorphic encryption. And professors that are advising Zcash are saying, we really do not understand if this works and how it works. So, I mean, if you're putting millions in currencies like that, you have to be warned that there can be vulnerabilities. But the largest attack surface is probably, as most things in crypto, related to entropy and random number generation. So if you have a wallet, and you have to start with good entropy, right? And you can't really make without good entropy, right? So there was a case, like a wallet which was very used at the time. It was blockchain.info wallet. They basically tried very hard to get good entropy. They even tried too much, probably, in their, if I remember correctly, in their Android wallet app. So they tried to get secure random, which is like from the Java crypto library. If it was not present because it was an old Android, they were getting from dev-urandom. If dev-urandom was not there, which is very rare, but it happens because some ROMs rename, I think, dev-urandom, or they disable it, or they don't make it accessible, or so on. They were doing something weird. They were connecting to random.org, and they were trying to pull entropy from that site. You know, random.org gets entropy from atmospheric noise, but they did it over HTTP first, which was a terrible idea in the first place. And when random.org moved to HTTPS, they put a 301 redirect to their HTTPS. The library that was not handling redirects correctly, so it was using the first bytes of the HTTP 301 moved permanently as the seed. So every wallet was generating the same address. And that was pretty bad. And of course, those funds were being stolen immediately, right after seconds, because there were bots that were just checking for those addresses and stealing the funds. So this is what comes to my mind right now.
Oh, that's that's super bad. I'm sorry for laughing. That's just like, yeah. I don't know if I could, like, if you'd ask me to invent the best vulnerability, I probably couldn't think a story of like fetching entropy from HTTP and getting hit by a redirect. That's amazing.
Yeah, that's a good story. There's also in the past it was there was a mnemonic. So before deterministic hierarchical deterministic wallets, they used to. Oh yes.
Yes, sorry, I switch you here.
They used to go. I mean, people used to go to Bitaddress. Bitaddress is. Yeah, Brain Wallet, sorry, Brain Wallet. Bitaddress is just what remains of it. So this wiggly thing is to generate entropy. It's kind of a placebo, to be honest. I mean, it makes sense. It used to make sense, but with web crypto, it's kind of a placebo. But never mind. Okay, so basically, you type a passphrase, which it can be, I don't know, like Bitcoin. Just because I want my funds to be stolen, I put Bitcoin. And basically, the SHA-256, or the passphrase, was fed to a password-based key derivation function and used as a private key. So if you do, I do view, It's now it's saying it's too short, and it's damn it. Let's do Bitcoin, because I mean this is how passwords work, right? It's too short again. Bitcoin. Ha! Now it works. So I generated an address, and of course this is very insecure, right? So let's see if people used it, by the way, because I'm curious now. So let's see if people.
The website is lagging.
I think a lot of people are using blockchain explorers right now. Yes, it's pretty impressive, like how yeah. Let's use less blockchain. Okay, no one uses that, so no one is using that. That's really bad. But test 1 2 3 4 5 6 7 8.
It's probably too short.
Yeah, 9. Damn it, 0. I want to generate a stupid address to show you that people are using it. Yes, let's try this one. Yeah, okay, I'm unlucky.
I can try.
Yes, but there are bots that are. This was actually presented at a security conference. It's called Brain Fryer, I think, and yeah.
Okay.
Yeah, try this one.
Look for it.
Yes.
Peace.
So people are. Oh yes, I can also try correct horse battery staple from XKCD. That's a great idea. Okay, so yes, people are using it. And by the way, is there...
Total received, but that doesn't mean
that's
it's silver.
Pretty awesome, actually. I think you find one with... Let me check. Oh no, okay. So it's empty, but people sent...
That's a good thing, actually.
So actually, you missed it for a while, right? I mean, can you see? So in 2013, someone sent money, but in October, someone stole it. The interesting part is that these funds are probably still in Bitcoin Cash, which is a fork that happened, right? So if it was there and it was not redeemed, yes, no. Damn it, no. Yeah, it's not there. But it would be interesting to see if old addresses still have Bitcoin Cash balance, because Bitcoin Cash was at some time, right? So if it was not stolen by then, it would also have Bitcoin Cash and Bitcoin Gold and Bitcoin Diamond and all the stupid forks that are being done. I'm also very curious about correct. Sorry, I have to do this, but it's correct horse battery staple, which is an XKCD reference, which you surely get. And I am sure that this is being used and it's being monitored. Here it is, and it received 15 Bitcoin. So this is, yes. Oh, by the way, in November 16, people stole $52. So you should really write a bot to. Just kidding. It's probably you. You have better things to do. But
so there are bots which are basically looking for these vulnerable wallets and grabbing funds out of them. That's it's pretty scary.
Let's see if the Bitcoin also the Bitcoin Cash is being raided, which is pretty cool. Anyway, yes. So a better way it's not to use, is to not use, of course, SHA-256, but to use a resource-intensive one-way hashing function like script. So what you can use more confidently, if you do not do this, right? You have wallets and you have deterministic wallets, but it's a warp wallet. So it's, by the way, now it's under Keybase. It uses a script with outrageous numbers of parameters that are very high.
Script, you mean a script, right?
Yeah, a script with a Y. Yes.
Oh.
So if you put even a pretty short passphrase here, like Ginvel, and if you want, you can put a salt. This makes it a little bit more resistant to Rainbow Table, but consider a large passphrase. No, I don't. See, it takes a lot of time to script it. It's script plus PBKDF. So it first hashes and then it and the number of rounds is very high. So basically these people had, right, so now we see that.
Yeah, I probably don't have this, hopefully. If I have my, like, I don't know, any Bitcoins there.
no one is there. So there was a challenge that no one redeemed, I think, just 8 characters only alphanumerics, right? Just to show how hard it is to crack it. There was 20 Bitcoin as a reward, and it's still not solved.
That's
And
quite a lot.
it expires on January 1, 2018. Yeah, it's a lot
so
of
okay,
money, yeah.
1 month left.
Exactly. So if you want, there is this challenge. And
I hope they actually bought it and put it on the wallet and did not wait until somebody brute forced it. Otherwise, the price might have changed. Cool. So let's go through the questions again. How will quantum computers affect blockchain or Bitcoin? Also?
Yeah, so I'm not a cryptographer, right? But this is also a common question, and there is a much more extensive answer on bitcoin.org, which is Bitcoin Core official site, which says exactly what will be affected and what will not be affected. The takeaway is it looks like quantum cryptography, if I remember correctly, quantum computing is mostly about breaking the discrete logarithm, so RSA, let's say, more than elliptic curves, but it might make elliptic curve cracking a little bit easier, but not trivial. But the important thing is Bitcoin is secured by both symmetric encryption, by both SHA-256 and elliptic curve. It will not make cracking SHA-256 easier, quantum computing. Also, these things like the SHA-256 and even the curve it's possible they are forward compatible. So basically they are future-proof. It is very easy to make a change in the protocol that would be a soft fork, by the way, so backward compatible, to adopt a new hashing function, or for example, there is already a proposal for SHA-3, and or a different curve even. Actually, the main concern about the curve is that being it a NIST curve, if I remember correctly, it's backdoored or things like that. But yes, here it is. And if you want like more like a better answer on this and what is affecting, what is not, definitely check bitcoin.org about quantum computing, and you'll see more.
Perfect. So let's go with the next one, which is actually related to mining a Bitcoin. So I guess everyone knows that you don't mine a Bitcoin on a CPU, right? Mining on a GPU is also probably a no-go. FPGAs were a thing, but now what? Just like normal chips, right?
Yeah, the ASICs, right?
ASICs,
so
yeah.
Using ASICs, yeah.
And this leads us into a question. So why is Bitcoin so popular in China?
How honest shall I be with this answer?
A technical answer, please.
A technical answer. Okay. Yes, so there are a few reasons probably, and here I am maybe also a little bit speculating, but one reason is that electricity in some countries is partially subsidized by the state, so it's cheaper. So it makes economically more sense to put mining farms in places where electricity is cheaper.
Like
And
the Tesla charging stations. I wrote an article today about it, that people are using the free energy from Tesla charging stations to...
I'm sure there is a way to abuse that. Yeah, so this is one reason. The other reason is I think some Chinese entrepreneurs have a higher let's say propension to risk taking. So while, for example, Europe and the United States lagged a little bit in the mining race, China was more into heavily investing from the first FPGAs to ASICs. So they have an advantage now. They have patents about micro optimizations of the hashing algorithm. So you can Google, for example, for ASIC Boost. Right? This is a patented optimization that makes mining almost 30% faster. So they license this optimization to their ASICs, so they also put, let's say, they have a technological advantage, right? From a more, let's say, economic point of view, we know that China has capital control, right? So it is hard to move money outside of China. And generating new currency that doesn't have a past by investing in hardware is a way to get money out of the country. So this is probably one of the reasons why people in some countries such as China or Venezuela more recently after the crisis, or even Russia, the countries that all have strong capital controls, are interested. are interested in mining. Yes, and also mining was a huge bet, right? Because it kind of I mean, there are calculators, mining profitability calculators, but it's been I mean, for a long time mining has been almost break even, and when the price exploded, it started becoming very profitable. So it was a bet, right? So okay, finally a block was.
So it seems that just the website wasn't refreshing.
Yeah.
Okay, cool. So the next question would be, what do you think about the Bitcoin's environmental footprint with regards to its electricity consumption?
That's another criticism, and I think it's one of the criticisms of Bitcoin that makes the most sense, in my opinion. So Bitcoin is definitely wasteful, and I think it doesn't make sense to deny that. Right now, proof of work is miners are I mean, let's not use like loaded terms. They are spending a lot of energy in solving a pointless lottery problem, right? Trying to find, basically guessing numbers, okay? And there is a lot of research in trying to make this proof of work puzzle more useful to humanity, like finding, I don't know, even finding some particular primes are interesting to science, or find protein folding, right? There is a coin that uses protein folding algorithm. The problem is, or researching cancer, I mean, via protein folding, for example. The problem is those algorithms are probably not as, let's say, they don't have the same mathematical guarantees of the uniformity of SHA-256, okay, or others good hashing functions. And so there might be a way to cheat, and if such a way is found, the whole scheme crumbles. So it is wasteful, but you have to think this way, in my opinion. How much electricity of energy are you willing to spend in creating a truly decentralized, trustless, permissionless payment system or store of value that combines the properties of gold and a little bit MasterCard and Visa? So if you compare it to MasterCard and Visa, which is centralized, it's definitely meaninglessly wasteful. If you consider it if you compare it to like moving physically gold is more expensive, right, from an energy point of view, than moving the same amount of, billions of dollars with Bitcoin. Another thing is, there was a nice paper very recently that estimated that while outrageously high, the energy consumption for Bitcoin mining were still less than what the United States spends energy in Christmas decoration in 1 year. So someone would say that maybe Christmas decorations are even more pointless than creating something that is still useful to a lot of people at a global scale. And I think that I would love to see a more environmental friendly proof of work, or moving to alternatives like proof of stake, but only if there is some kind of guarantee that it is at least as secure.
Okay, so I guess there's like a follow-up on a question, like basically, what are the consequences of global power, like suddenly you lose all electricity, what happens to Bitcoins?
It would be a problem for mining, right? So mining is decentralized, so you would need like no electricity in all the world, right? So that would probably be larger problems, right? Food processing without electricity is very hard, right? Yes, it would be a problem. So Bitcoin transactions can be relied offline, right? You don't need an internet connection to verify a Bitcoin transaction. So you can accept an offline transaction very easily, and some wallets also allow that by just scanning QR code. So payments would still work. I mean, credit card payments do not work without a connection, right? But Bitcoin would work. Mining would be a problem. So if no miners in the world would have hashing power, with no electricity, yes, the blockchain would not advance. So that would be a problem, yes. But we would have probably other problems such as, food.
Okay, so I'm going to mix the questions a little. What will happen after the last Bitcoin is mined?
Yes, so when the reward approaches zero, it never goes to zero, it approaches zero. So there is really no last Bitcoin, because it's, you have to halve every time, it never go to zero, right? Like the turtle, right? But anyway, when it becomes almost irrelevant, zero, miners will live out of fees, transaction fees, and the money would be just redistributed among people with transactions. And this will happen in 2051, right? So there's a long time to go there. Yep, that's the thing. And it will be even more deflationary, right? Because people will lose their private keys and so on. But by then, probably Bitcoin will be very different, or it will not be called Bitcoin, or it will be integrated in ways that the end user will not even know it's there.
Perfect. Okay, so this is a good question. Actually, well, I guess, well, I'll let you answer it. Who is giving money for the block reward?
No one, the protocol. So the protocol says if the block height is in those ranges, then there is a block reward. And you can claim it after waiting time. The miner can claim it after waiting time. It's called Coinbase.
So what's the waiting time?
It used to be 150 confirmations, so 150 blocks.
That's quite a lot.
It's a lot, yes. And there is a reason for that.
And also,
because it is an incentive. At the beginning, it was an incentive for miners to not overwrite history by doing things such as greedy mining or things like that. Selfish greedy, there are a few variations of bad things you can do. Basically, if you cannot spend the Coinbase immediately, you have more incentive to. So one important thing is that Bitcoin doesn't rely on miners being honest. Bitcoin relies on collective interest serving, self-interest serving the collective interest. So miner rationality serves the good for everyone, right? And this is what also happened in the forks, right? In the recent forks. So this is very interesting. It's from an economical point of view too. Also, if you think about like the tragedy of the commons and things like that, it basically turns it upside down, right? So it's pretty interesting.
Okay, are only donations in Bitcoin accepted today? No, by usual means, like super chat and so on. Again, any donations will go to a charity of Mickey's choice, if any.
But we can generate an address with Coinbin maybe and show the address if you want. Including
the private key.
Oh, right. Well, we'll not show that. It's by default. It's not shown by default.
Okay, this one we already addressed. Okay, what would happen if countries start to block Bitcoin because they don't want it to interfere with banks? Bitcoin is only worth so much because people can buy it. Would the bubble burst?
Okay, so this is also a common question, right? And so it's interesting, right? Because there are a few assumptions, right, behind these questions, which I don't particularly agree on. So countries cannot block Bitcoin. Okay, so Bitcoin nodes are hundreds of thousands. They are everywhere. It is very hard to block Bitcoin, right? So what can happen, for example, if ISPs try to some I don't know, BGP tricks to, and there's been academic papers about that, to deviate or mostly make Bitcoin networks slow, right? What would happen? Bitcoin peer-to-peer network is extremely resilient and extremely well coded. So it would really need to be a word scale attack on Bitcoin. If it is just by one superpower, it would very likely not be a problem. There is this like insider joke that China bans Bitcoin, right? So China, of course, by applying capital controls, might see Bitcoin as a problem, right? What we are seeing so far is that also about banks, right? Is that banks feel threatened, but they also think that they can handle that. So there will always be a need for services, maybe over Bitcoin. For example, I will not make the name of the bank, but there is like the first private bank of Switzerland. Okay, maybe I said that by saying that, decided to offer custodian services over Bitcoin, right? Regulators in most countries are embracing Bitcoin and especially blockchain. So there is this narrative, you know, we like blockchain, we don't like Bitcoin, right? Which is very dangerous and not very meaningful. And banks like more than, I think it's more than 100 banks formed this consortium. It's called R3 Consortium, and they developed this open source permissioned, it's called permissioned blockchain. It's kind of a private blockchain called Corda. And after investing a lot of money in the technology, they realized they probably don't need blockchain, right? I mean, they probably just needed maybe sometimes a Merkle tree, sometimes, you know, some kind of immutable ledger, but not the concept of blocks, for example, or a lot of things. They don't even need to solve the distributed consensus problem. But anyway, what I want to say is that it is very likely that banks will see and are seeing Bitcoin as a way to provide more services. For governments, it is not a problem yet. It might be a problem, for example, for tax elusion and tax evasion, because it is hard to prove how much money you have with Bitcoin, right? It's not visible on the blockchain unless you spend it. But I really think this is one of the least likely scenarios in which Bitcoin will fail, like by government crackdown. It is much more likely that Bitcoin becomes obsolete technologically, or there is a loss of interest, or yeah, some kind of technical disaster more than regulation and governments.
Okay, perfect. So another fields of blockchain usage apart from, I guess, coins. I saw some companies like SAP claim to use this, but how and why and so on. So what is blockchain use?
Absolutely. I mean, blockchain is a kind of a cool now, right? I mean, everyone wants to do blockchain, and most of the times you don't need blockchain, right? I mean, you might need a database, right? Blockchains are particularly bad databases, right? So blockchains do not scale. Blockchains are distributed, but not the way people think they are distributed. They give very strong, for example, guarantees about immutability, resistance to hacking, and so on, but at a cost, right? So this cost is mostly, they are hard to scale. Okay, so there are a lot of ways in which blockchains can be used for other things that are not just using currency. So you can have any asset on a blockchain. You can have a house, you can have music, you can have stocks. So you can replace a stock market very easily with smart contracts, right? So there are projects about that. NASDAQ is experimenting with option settling, settling automatically with smart contracts, which is pretty cool. And blockchains might have also might be used in for logistics, so for supply chain to prove that no one tampered with the supply chain of food or transportation of goods and so on. It can be used for as a land registry, right? So, for example, 2/3 of the world two-thirds of the homeowners in the world do not have a full title of properties, right? So since most of them are unbanked, they don't have access to a bank account. If they can't prove that they own land, they can't put it as collateral to a loan, so they can't get a loan and they can't make projects for the future, right? So maybe if we are in Europe or in America, in the US, we don't feel this as a huge problem, but 2/3 of the world people have this problem. And using blockchain to basically have immutability for something like that. So in South America, especially in Honduras, right, this problem is very felt, right? So when governments change, records get lost, okay, and this is a problem. So Honduras experimented with a blockchain-based land registry with a lot of success, and this is actually pretty easy. It's not very hard. You just have a distributed, tamper-evident record ledger of that. Lastly, intellectual property is also a very interesting case. You can, for example, Imogen Heap, if you like her, the Grammy Award winner singer, she moved some of her music on a smart contract system called Mycelia, and it enforces intellectual property rights by itself. It has an integrated payment system based on Ethereum, and if you want to just listen to it, it's free or it costs a few cents. If you want to use it as a phone it's a phone ringtone, it costs a little bit more. If you want to use it for a movie, it costs more. And since it has an integrated payment system, the money stays in the hand of the content creator. So I would say there is a trend, and it is like with removing intermediaries, right? And it already started with companies such as Uber, Airbnb. The largest hospitality company doesn't own any hotel, right? And the largest taxi company doesn't own any taxi. Now it is becoming even more decentralized, also thanks to technologies like blockchain.
Okay, perfect. So we got a donation, actually. Donation is from Paweł Lukasik. It's Bitcoin is dead, long live Polish coin, and 25 Polish zlotys. Thank you. Cool. So okay, so how do you monitor a blockchain? I guess like from a technical network perspective, are there any hosts? Do they have APIs? How do they exchange? How does a peer-to-peer protocol work? How come the trade block site can actually show us stuff? How does it work?
Advanced monitoring of the blockchain also involves having sentinel nodes that, for example, do very complex calculations, that have also to take into account the network infrastructure, the internet infrastructure, to see, for example, where a transaction originated, which is not easy to find at all because it uses a flood-based flood. It's a peer-to-peer terminology which I don't remember very well now, but it's basically by design it's hard to say the originating node of a transaction, and this is by design. But anyway, the blockchain itself gives plenty of information, right? Because the blockchain is transparent by default. So Bitcoin is not anonymous, Bitcoin is pseudonymous. The pseudonymous, it's like being in a chat with nicknames. Your nicknames are your addresses. If you reuse them, you use them for several transactions, you group them together, you are associated your identity, you are grouping together addresses in clusters. So this was actually my master thesis in 2011 and 2012, which was pretty ahead of time. Bitcoin was not mainstream yet. Bitiodem was grouping together addresses in ownership clusters. So there are a few ways of doing that. The first is multi-input addresses. So if you have multi-inputs, you own the entity that broadcasted, unless you did something weird, the entity that broadcasted the transaction owns the private key of all the input addresses. So probably all the input addresses are owned by the same person. This has exceptions, right? For example, you can just sign one input and give it to a third party to be broadcast, and they can group it. Actually, some anonymizers that are called mixers or tumblers work exactly this way. Secondly, there is this concept of change address. Since unspent transaction outputs have to be spent fully, you need to create a new address as a change to collect back the change. Actually, there was a bug, an off-by-one bug in Bitcoin D that made the position of the shadow address, it's called shadow address, the change address, predictable for years. And I built a software that exploited that, and it was very, very easy to build clusters thanks to that vulnerability. And there are a few sites that can show yes, thank you very much, like these things. So one doesn't work very well usually, but it's oxt.me, but didn't work last time I checked. The other is walletexplorer.com. So this is pretty cool, right? So for example, you see these are the exchanges, and maybe you see it better now. These are the mining pools, these are services, this is gambling, right? So for example, let's go to primedice.com, which is a dice. You know, Bitcoin enables cryptographically provable fair gambling. So it's a big thing, right? Prime Dice, you see this wallet has a lot of addresses, like, so all these addresses has been grouped and identified as part of this website. So if you're sending money to Prime Dice, it's very likely that a software like this can tell that you send money there. This is why it's important to change addresses. Okay, so you see, for example, I don't know, so someone sent from Xapo, which is an exchange. Someone said from Happy Coins, which I don't know what it is. Well, someone said from Mt. Gox. Yeah, this is from 2016, right? Mt. Gox is a failed exchange, and Yeah. And so on, right? So walletexplorer.com, very nice site to see addresses that are known to be part of ownership clusters. If you're interested in this, you can also search for BitIodine. So on my GitHub, if I may, github.com/MikisPack. So BitIodine is historical. It's just historical now. It doesn't. It used to have a few components like a classifier and so on, but now the only part I maintain is the clusterizer, which is now written in Rust. Yep, and it's based on a Rust block parser. And this is the code I wrote, and it's pretty cool. I also use it for anti-abuse for some services, and it works very well. And so on. If you're interested, just go to my GitHub, and you'll see more. There are of course more advanced ways, like by, for example, actively putting some money in something, and then what's called taint tracking. So tracking the taint of the coins.
Okay. So this is, I guess, a pretty similar question. How does the mempool work? Who has it? And how does the mempool get synchronized between nodes?
Okay, so every full node of every Bitcoin full node has the mempool. Okay, so it is present in all nodes. And sometimes it's in memory. This is why it's called mempool, right? Because it has particular data structures to be very efficient. And what was the second part of the question?
How do they get synchronized?
Oh yes, this is with the Bitcoin peer-to-peer protocol. You have to, sorry, I hope I didn't close important things. Yeah, it's via the Bitcoin peer-to-peer messages. And yes, so it is particularly important for miners to have an updated view of the mempool, right? Because they don't want to miss a very high fee transaction. And so there are some other, I hope I remember, but I think it's called Bitcoin Fiber Network. Yes, Fiber, but with the RE. It's a protocol implementation to relay blocks beyond the speed of light. Yeah. I mean, seriously, like this is really crazy stuff, but this is for block propagation. This is slightly different. It's not from mempool, but there are some pretty advanced technologies behind this, and it's like high frequency trading. Since a lot of money is involved now in this thing, they are really putting serious resources in researching this. There are a lot of academics putting efforts in this.
Okay, I guess the question, especially for you, even though all questions are for you today, have you looked at this thing?
Nope.
Okay. And this thing being BitCluster. Okay, the answer is no. Then.
I haven't. So when I wrote BitIodine, it was 2011. I saw a lot after that. Luckily, there was a lot of interest, and I will look into that. But BitCluster, I don't know about it. My BitCluster. Matteo, yeah. It's bitcluster.com. Oops, sorry.
Oh,
yeah. Anyway, it's in Python. De-anonymizer. Yep. I guess this is similar to OXT by Laurent Salah. I will definitely have a look. But no, I didn't know about it. It is not the only one, right? There are startups like Chainalysis is the most well-known. It's a blockchain analysis. There used to be others. I know most of the people in this field. Sometimes they are catering to governments. Sometimes they're catering banks to banks. Sometimes they're catering to gambling sites or other Bitcoin service providers. They want to do anti-abuse mostly, right? Yeah. There's a huge market.
Okay. How does Bitcoin guarantee that my transaction will be put in a block if I use a very small transaction fee?
It does not.
It does not.
It does not. After approximately 72 hours, it will disappear if the fee was not enough and you're not lucky to have a generous miner. a miner kind enough to embed your transaction, your transaction will fall out the mempool, and then the funds will be, it will be possible to spend again the funds, maybe this time with a larger transaction fee, or wait till the network, there is less traffic on the network so that the fee goes down.
So I guess like there's also a question which you already touched upon today, is like after how many new blocks that do you actually can assume that, well, my transaction went through? Because like you can also, I don't know, I think there were some abuses like that. You could send some Bitcoin but put fee as 0, and then after 72 hours you'd get your money back, and somebody might trust the
most merchants nowadays accept so-called one confirmation deposit. So basically they wait till the first confirmation. So once it is in a block, it is very, very expensive to override history, competing with all the miners. You basically would need a lot of miners colluding with you, and this is very expensive because they are losing hundreds of thousands of dollars by doing that every minute. And it basically costs millions of dollars to override a one confirmation transaction. Accepting a 0 confirmation transaction, which means in the mempool, you can do it only if you have very good heuristics of so-called transaction velocity. So basically you need to check that. So in the past it also had the so-called age of coin or transaction priority in the algorithm. Now it's basically just fee over size, or more precisely fee over weight unit, because after SegWit it's called weight unit because it is variable. Basically sites such as fee estimation sites usually give a pretty accurate estimation of how long it takes. So if you for example use BitPay or like merchant services for merchant for accepting Bitcoin, they sometimes accept 0 confirmation transaction, so immediately if the transaction is high enough for them to be confident that it will be added to a block. It can be a little bit more complicated than that because there is a technology called replace by fee. So if the transaction is marked and it is opt-in as replaceable by fee, it can be overridden while it is in the mempool and still not confirmed by a transaction to the same address or even to another address with a higher fee. So if it is replaceable by fee, you should not accept a 0 confirmation one, but it is opt-in and by default it's not replaceable by fee. There are also a few ways to speed up transactions that are stuck. For example, there is children pays for parent. So basically, the recipient tries to spend the unconfirmed input, putting a large fee. So the miners will see this chain of low fee input and then spent again with a high fee, and say, okay, I need to also get the burden of the first one to be able to get the larger fee for the second one. And there are techniques like that. Also, there are transaction accelerators, but they are mostly goodwill from miners that just have forms and just say, put your transaction IDs and we'll speed it up. Some of them simply do not work.
Okay. So, how is Bitcoin distributed if most of the computing power is gathered around very few people, like mining centers or pools? And normal users are not expected anymore to hold and process the entire blockchain on their disks, and even mobile devices, because of its size. So why do we still call it distributed?
Yes. This is a very good question. It's true. So miners are, especially geographically, very centralized in one area right now. We have almost 50%, I think, of miners that are in China. And this is a huge problem, also geopolitical. There are several actors in the Bitcoin ecosystem. Miners, so very important, the rules of the network are enforced not by miners, but by nodes, and especially by fully validating nodes. Okay, so it is crucially important to run full nodes. Right now, it is very cheap to run a full node. You basically just need disk space. You can run it on 256 meg of RAM and with really few computing power. You can run it on free test instances in most cloud computing services, on a Raspberry Pi and so on. So the rules of the network are enforced by nodes. you don't need the full blockchain to validate the rules. It's true that SPV nodes and light nodes are not validating nodes, but they rely on a validated nodes. Okay, so there has to be a validating node somewhere. Okay, there are light wallets that are also validating, but they just have the header of the block. So you don't need the whole transaction data. So by the way, Bitcoin Core right now by default doesn't store the whole transaction index. You have to put tx index equal 1 in bitcoin.conf to have that. And it has automatic pruning. So it removes old blocks and then assumes that at a certain point, it's called checkpoint, the blockchain is at a sane state. It doesn't verify back to the genesis nowadays, because there are checkpoints, and this is how to speed up synchronization. So you don't need a lot to be validating, and it is absolutely important that there are validating nodes, because it's not about miners, right? So miners can cheat, but the nodes will not accept the blocks. Okay, so they are the nodes that are the judges. Okay, you don't need computing power. You need computing power to secure the network. You don't need computing power to validate the rules of the network. So every full node is a cop of the network.
Okay, so this is an interesting question. So given the amount of power the Bitcoin network has, what other problems could we solve using that computing power? And for example, is cracking AES 256 one of them? Could we crack like even one block of AES?
I don't know, maybe. I think a lot of more useful things could be done with the same computing power. Bitcoin and the proof of work of Bitcoin has been defined as the largest distributed pre-image collision attack on SHA-256, right? Because it's basically finding a chosen prefix on, I mean, with the chosen prefix 0000 hash. So if you can do it more efficiently in any way, you have a huge advantage in mining. Right. So it's that's a very good question. I mean, yep, surely you can do much more useful stuff. I don't know about AES 256. I don't know about that. You probably mean. So do you mean because it's usually SHA is used as a password-based key derivation function, or I mean, I don't get exactly the
so
from
for
SHA
example,
to AES.
Forget the SHA. If you take the same computing power, which is used on Bitcoin,
yes.
right? What can you crack AES with it?
So if you're talking about ASICs by definition, they are application specific, so they can just do SHA-256.
Yeah, but if we like suddenly like the universe changes, or there's a parallel universe where we have always like the same computing power applied to a different problem, what problem could that be?
Oh, sure.
Like for example, I don't think AES could actually be cracked with that.
I don't think so. I think it's a very different thing, but
yeah, it's still too little.
I don't know. I think it put a huge bounty on SHA-256 being pretty resistant.
That's true. That's true, actually.
But yeah, I mean, the same computing power. Yeah, it's very interesting. Maybe it would have solved. I mean, it would have found a cure for cancer.
Yeah, who knows? Okay. So, how do you detect a DDoS attack, and how is it implemented? I guess it's in the context of cryptocurrency.
This is a bit of a generic question, right? So there are ways of attacking. Usually denial of service in a blockchain like Bitcoin is done by polluting the mempool with so-called dust transactions. So just very low fee and huge transactions that just put unnecessary strain to the network, or they fragment UTXOs in a lot of very, very small slivers of Bitcoins. So this is usually countered by the transaction fees. So transaction fees are not enough, they just fall out of the mempool. So the mempool becomes full, and this is something that happened, unfortunately, so there were a lot of attacks. I don't want to accuse anyone, but let's say that there were some actors that were particularly interested in showing that Bitcoin was low and the blocks were full, right? So to show that, they also spammed the Bitcoin network. This is everything is transparent, right? With nonsense transactions. They just polluted the mempool, but they all fell out of the mempool because they didn't meet so they say the anti-DDoS mechanism of Bitcoin is the transaction fees. If we didn't have transaction fees, dust would be a problem, right? there is limited capacity to everything. There is limited computing power. In Ethereum, for example, this same concept is implemented with a different way, which is called gas. And you can specify the maximum computation that you want to use on the network, and it's different. So, by the way, the proof of work, the idea of using a proof of work for countering, this is not exactly the same thing, but it came to my mind, to countering abuse is not new, right? Adam Back wrote Hashcash for fighting spam. So the idea is you have to basically mine a little block, like having a hash that has zeros. It was exactly that. It takes maybe 2 seconds for a normal computer, and it's fine for one email, but for spammers it makes a huge difference, and it becomes much more expensive to send spam. So it didn't work for a few reasons, and mostly because email protocol is a little bit funny and it's a little bit legacy, as you all know. Yeah, so Adam Back used to say Bitcoin is Hashcash with inflation control built in. It's a little bit reductive in my opinion, but it's a fun way of seeing it.
So how can I make my own cryptocurrency?
Why should you? I mean, if you think you can do better, you can probably contribute to Bitcoin, or I mean, of course, you can start your own cryptocurrencies. Like usually, you fork, most altcoin or alternate coins are created by forking an established one and modifying a few things that you think needs to be changed. Then you need some economy to form around it, so some ecosystem. You need exchanges to accept it. And if it is just a fork, maybe they won't, because they won't see the, let's say, the rationale. Why should it have value, right? But for example, if you do interesting stuff, well, then you need exchanges to accept it. You need wallets to implement it, and then yeah, well, it has to be open, right? Because otherwise, probably no one will use it. You should not pre-mine it, because it's a red flag. And the first altcoins were all pre-mined, and now it's no longer fashionable. You just get ignored. But just see what's happening. You have Bitcoin Gold, the Bitcoin Diamonds. I mean, yes, it exists, Bitcoin Diamond. They make no sense, right? They have no reason to exist. This is my opinion, right? But so Bitcoin Gold has this idea of dividend, for example. Bitcoin Diamond, I don't even know if they have any proposition. They want to be slightly faster, I guess. So being cheaper and faster because no one uses you is not a very compelling argument, right? So Bitcoin, there's a reason why people pay fees on Bitcoin, because Bitcoin has 80,000 times the computing power, is secured by 80,000 times the computing power of the top 500 supercomputers together. If you and your friend are mining your coin, it is super insecure, right? And if it's proof of work based. So in fact, you also need miners to have a proof of work based coin to take off. So either use proof of stake, which comes for free, or you use some other ways. But the idea is we're probably having too many altcoins already. Maybe if you have an idea, you should post it on a Bitcoin Dev mailing list, or contribute sending a Bitcoin improvement proposal, BIP, and so on.
Okay, how can we be sure that we are mining a theoretical problem with routing via SHA collision, and we aren't really cracking some cipher for somebody? So are we sure that Satoshi doesn't need to crack some SHA-256, and we
well,
are
as I
doing
said,
it for
it's
him?
pretty transparent what you are doing, right? You are doing SHA-256 twice on a block format that has some bytes that are fixed, and everything else is malleable. And you need to have a number of 0 bytes in the beginning of the hash. If you know what this is, sure. Otherwise, there's nothing secret, right? I mean, what's the reason why it's being done that way? It's written in the white paper. Are we cracking something in particular? Well, we are testing how good is SHA-256. If we saw, like, we know how good ASICs can become, right? If we see one miner becoming 10,000 times more efficient than the others, it probably means that it found a loophole in SHA-256, right? This would be a problem. It will get probably a lot of rewards in the beginning, and probably there will be a soft fork in Bitcoin to change the proof of work. There are contingency plans to change the proof of work in emergency settings, and they are already ready, like they're just ready to be pushed. There is SHA-3, for example.
Okay.
And SHA-3 is also pretty cool, like it has some other properties.
I guess like if somebody cracks SHA-256 in a good way, then we'll have more problems than just Bitcoins.
Absolutely, yes.
Okay, what would happen if the elliptic curve used in Bitcoin is found not to be safe or actually have a crypto backdoor? What will happen then?
Same, it is future-proof, so you can change the curve with a soft fork, so a backward-compatible fork. And this is probably the most likely scenario, by the way. If some crypto is going to get it broken, in my opinion, it will probably be the curve P256, more than SHA-256, in my opinion. I don't remember if that was the NIST recommended one, but let's not get into conspiracy theories.
Okay, what incentives do banks have in converting currency to Bitcoin, if they have any, and I guess also like exchanges, like Bitcoin exchanges? Why do they exist? How are they earning money?
Well, they don't, right? Because I think they can't from a regulatory point of view, unless clients ask them to. I don't think with the fractional reserve concept, I'm pretty sure they can't just convert fiat money to Bitcoin just to profit. I mean, it would be awesome, because they would have done 9 times. They would multiply it by 9 their funds. But what incentives? Well, it's a very good investment. It's been a very good investment so far. Okay, so if you are a merchant and you're accepting Bitcoin with BitPay, for example, you can choose to keep part of the Bitcoin and convert part of it to fiat money, to dollars or euro. And if you do that, you basically, you want to keep Bitcoin, right? Overstock, which is a publicly traded company in the United States, decided to do exactly that. It's keeping, I think, half or a fraction, probably even more than half, in Bitcoin. And this is the reason. May I show something?
Yeah, sure. Go ahead. Sorry, desktop. There you go.
As I said, you know Overstock.com, right? Overstock.com is it's like basically Amazon site, e-commerce. And if you go to the stock and you see what happened in 2017, this happened.
Okay.
It tripled. Okay, so waiting for proper Bitcoin ETFs, people are using Overstock stocks as a proxy to Bitcoin. Okay, so this happens when companies keep their Bitcoin.
Okay, that's quite interesting. So changing a question a little, if we have a Bitcoin exchange like, I don't know, Coinbase or something, right? How do they profit?
They usually profit, so if they are just an exchange, they profit out of trading fees usually. Mm-hmm. So they usually have, not all of them, but they have a market maker, market taker fee schedule. Usually it's around 0.1 to 0.25 usually %. And this is their main source of income. Yeah, that's it. It's mostly transaction fees. When they allow also leverage trading, they also have a markup over borrowing fees. So if you borrow dollars or euro, they charge you. And it can be also pretty substantial. So they earn even more.
Okay, perfect. So, Verify Your Wallet program will do the work for anonymity. Do you have a comment on that?
By hiding your IP address, if you're using your own full node to broadcast a transaction, then the IP address of your node might be linked to the transaction. So using Tor, you will see a Tor address, right? But this is not the main source of linkability on the blockchain. Linkability on the blockchain is due to address reuse, mostly, or sending to an address that's been classified as part of a cluster. So Tor doesn't really help with that. So Tor helps in hiding your identity if you're using your full node to broadcast a transaction, which is no longer very common, because usually you're using just a wallet app, and then you're using basically the servers of of the wallet app to broadcast a transaction. So the transaction is just a sign, doesn't have your private key, right? It just has the signed transaction. So Tor really doesn't help a lot, right?
Okay, so about the question of giveaway, I need to check if the book is available, and I will get a few copies so we can do a giveaway next week with it. That's a cool idea, by the way. Perfect, so I guess we ran out of questions, so thank you, Miki, for today.
Thank you very much for having me.
Yeah, thank you everyone for being here. Thank you especially to Krzaku for being the moderator today and for helping us. And yes, that's about it. So see you next week. And again, there is no mission today, and Mormos is already started streaming, so go and check out his channel. So that's about it. Okay, see you next week, and I'm leaving you with some music. Thank you again, Miki.
Thank you.